Hi, welcome back to my channel. In this video, I'll be talking about ketone bodies and all the important points that are needed for you to know. So first of all, just a general idea, ketone bodies usually occur when the metabolism in the body basically favors more beta oxidation. So occurs when beta oxidation of fatty acids is high. All right, now when does it occur? This I have told you. So primary ketone body is just replace it as where does it occur, where. So it occurs in the liver. So it occurs in liver, that too mitochondria. All right, then primary ketone body is acetoacetate. These are one-liners. I will be explaining them. Then secondary bodies are two: beta hydroxybutyrate and acetone. Then concentration of ketone bodies in blood, it is always less than 0.2 millimole per liter. All right. Then organs that do not utilize ketone bodies are RBC, liver. All right, then coming on to the synthesis. Now for the synthesis, I will be walking you through the pathway in a very easy sort of manner. So first of all, we know that acyl CoA, right, it undergoes beta oxidation and it forms acetoacyl CoA. All right, then this through thiolase it forms acetyl CoA. Now this acetyl CoA, now the real thing happens through HMG CoA synthase forms HMG CoA. Now this through HMG CoA lyase will form what we need is acetoacetate, which is our primary ketone body, right? So primary ketone body. Now through the acetoacetate, what will happen is there will be two things. One is decarboxylation and dehydrogenation. So when we will do decarboxylation, we will get acetone, and on dehydrogenation we will get beta hydroxybutyrate. Now both of them are secondary ketone bodies. All right, now this much I have told you, right? So this is basically the ketogenesis. Then remember that the rate limiting enzyme is HMG CoA lyase. So site I told you in liver, mitochondria, right? The substrate is acetyl CoA, right? This is our substrate. Then rate limiting step or rate limiting enzyme is HMG CoA lyase. Okay, pathway we have done. Now now I had to erase this, but anyhow, in brain what happens is see, I will tell you two things that will not utilize the. See, I already told you that liver and RBC do not utilize ketone bodies. So in starvation, they are utilizing amino acid and glucose. This is something you have to remember. Now, let's just go through it one by one. Brain in fed state, obviously glucose. In fasting, it will use glucose. In starvation, it will use ketone bodies. Heart also same thing, but fed and fasting with fatty acid. Muscle is also utilizes ketone bodies. Just remember it. All right, RBCs in starvation state will utilize glucose, and liver in starvation state will utilize amino acid. This is the question. All right, then we will talk about glucagon and versus insulin relation. Now to know ketogenesis, you have to know 2-3 things to understand what is happening. All right, now just know that see, factors affecting ketogenesis. So factors affecting ketogenesis. So first of all, we have glucagon or epinephrine. Now what happens is glucagon, it basically, just remember, it increases the beta oxidation of fatty acids. Now because more beta oxidation is occurring, then more ketone bodies will be formed because the substrate is acetyl CoA. So obviously you will have more of the substrate, right? So that's why. Then second factor is malonyl CoA. Now there is very important thing that you should know. Malonyl CoA basically inhibits the ketone body formation. Okay. What happens is in beta oxidation, basically if we talk about beta oxidation, or basically talk about lipolysis, so what happens is we have TAG, right? Then it gets converted into fatty acids. Now fatty acid synthase, and there is CoA, है ना, which form fatty acid, and then it goes inside, and then over here there is an enzyme which acts on it. This enzyme is carnitine acyl transferase 1. Now what happens is malonyl CoA, it inhibits this enzyme carnitine. Now due to this inhibition, what happens is there occurs decrease in ketone bodies. So just remember that malonyl CoA, it basically what it does is it inhibits the carnitine acyl transferase 1 enzyme, which is the rate limiting enzyme of beta oxidation. So if I told you in the first line itself of this video ki ketone bodies will occur when there is more fatty acid oxidation, so if it is inhibiting, that means it basically decreases the ketone body formation. All right, then if we talk about insulin, basically insulin, whenever there is less insulin, there is decrease in malonyl CoA. So what happens is increase in ketone bodies. That's why you see that in diabetic ketoacidosis, basically it occurs when we have type 1 diabetes mellitus, right? Then there is one more, HMG CoA synthase as a factor. HMG CoA synthase. Now what happens is this HMG CoA synthase, see, we had HMG CoA synthase here, right? So its induction will basically increase the production of ketone bodies, right? So what happens is there is increase in the transcription of HMG CoA synthase in conditions like fasting, increase intake of fat, and diabetes mellitus. So all of these also lead to diabetic ketoacidosis. All right, so basically if now I ask you this question, what is the relationship of glucagon to ketone bodies, basically to ketogenesis? So what you will say is glucagon increases ketogenesis, insulin decreases ketogenesis. All right, then coming on to the ketonemia. Now this is basically ketone bodies in blood when the level exceeds more than 1 milligram per deciliter. Ketonuria is ketone body in urine. Now ketosis, very important. Now ketosis can be of 3 types. All right, so first of all we have physiological ketosis, or you can call it just give me a second, or you can call it physiological, or you can call it nutritional. Okay, then you have ketoacidosis only, but of 2 types. One is diabetes mellitus ketoacidosis, or basically diabetic ketoacidosis, and then we will write it as diabetic ketoacidosis, and second is starvational ketoacidosis, right? Now just know what I'm telling you. In physiological, basically nutritional, it is a normal response to low glucose availability. Now what you are understanding is we see celebrities taking keto diets, right? So what they're basically so they, what do they do, they do low carbohydrate diet and they take more of protein. So it's also called as Atkins diet. Okay, and in fasting. Now in this what you need to know is in all this you will have normal acid base balance. All right, but in diabetic ketoacidosis and starvational ketoacidosis, what will happen? In diabetic ketoacidosis you will have hyperglycemia. All right, in this you will have hypoglycemia. Then you will, in this one you will have positive Rothera's test, basically in both, but in this you will have Benedict test also positive, but in starvational you will have Benedict test negative. All right. Now, in diabetic ketoacidosis, what you need to know. So these are the two places where you will see, two conditions where you will see ketoacidosis, diabetic ketoacidosis or starvation ketoacidosis suffering. Now, in the features of diabetic ketoacidosis, first and the foremost is metabolic acidosis. Now, what happens is there is an increase in H positive. To basically stabilize it, what happens is we lose HCO3, so we have reduced buffer. Okay. Then third point is Cosmol breathing, very important. In this is basically what I say is acidotic breathing due to compensatory hyperventilation. So what is the characteristic feature is deep and rapid breathing. All right. Then the feature that everybody knows is acetone breath. Okay, fruity smell, right? Then osmotic diuresis, because we are having reduced buffer. Okay, so osmotic diuresis, so dehydration. Then there is sodium loss also. Then last is coma, which is the most dangerous state. All right. Then ketolysis. Now, what is ketolysis? Is basically the breakdown of the ketone bodies. Now, for the breakdown, you just need to remember that there is an enzyme, thiophorase. Okay. Then Rothera's test is basically what happens is you use sodium nitroprusside, and you have basically purple ring formation, which is positive test indicator. Now there is Gerhardt test. Now for both these tests 1 and 2, just know that it will be positive in acetate positive, but beta hydroxybutyrate will be negative. All right, then one of the most asked MCQs these days is why is liver not able to utilize glucose, or why is RBC not able to utilize glucose? Now for that, I think I included it somewhere, but I can't find it. So I'll just tell you. Now liver, RBC. Now they can't utilize ketone bodies because they lack the thiophorase enzyme. All right, so this is basically the crux of ketone bodies in a very easy, simple format, and I hope I made it easier for you to understand. If you like the video, do subscribe to my channel. Thanks for watching.